Hello everyone and welcome to my channel. In this video I will be talking about cell class in Kotlin. Let's begin with the definition of cell class. Cell class represents restricted class hierarchies and all direct subclasses of cell class are known at compile time. So let's understand this definition by a simple example. Imagine two neighborhood A and B. Neighborhood A has a special club for pet owners and this club has a special rule for membership, and the rules are: membership is exclusive to only owners of cats, dogs or birds, and there is also another important rule, which is new members can only be from neighborhood A, it cannot be from neighborhood B. So now let's connect this example to Kotlin cell class. Think of cell class in Kotlin as similar to the pet owners club in neighborhood A. If you remember, the club only allows certain type of pet owners to be part of the club. It is same with cell class, where you can only have a certain specific type of subclasses like the different pet owners. Also, just like the club only allows member from neighborhood A, in Kotlin these subclasses have to be in the same part of the program or the module. And this setup demonstrates the first point of the definition, known as the restricted class hierarchies. So where the class hierarchy is limited and controlled. And because of this restriction, the Kotlin compiler is aware of all the potential subclasses of the cell class, which ensures the type safety and comprehensive handling of the subclasses. So this is similar to how the club management knows every member and their respective pets. And having discussed the theoretical aspect of cell class, let's now move on to clarify this concept through some practical coding examples in Kotlin. The syntax for creating cell class is cell class and then followed by a name. So let's call it pets owner club. Now let's create the subclasses. To create subclass in Kotlin, just use this class keyword followed by a name. I will name this cat owner and then followed by a colon and then name of the cell class, which is this pets owner club. And then you also need to add this bracket. Now let me copy this class 2 times, and then I will call this dog owner and I will call this bird owner. And then inside each subclass I will create a function called print owner name, and then this will simply print the name of the owner. So let's name this owner as Alice, and for dog owner I will call this Bob, and for bird owner I'll call this John. So these are the subclasses with their respective functions. Now let's create another function, and this function will help us to understand or see the actual use case of the cell class. Let's call this function get owner name, and this function will simply print the name of the owner. For example, if it's a bird owner, then it should print the name John. And this function will also receive a parameter of type pets owner club, which is our cell class. Inside the function, let's use when expression to handle the different type of pet owner. Now if you move your cursor over to this when expression, it will show us an error message which says that when expression must be exhaustive, which means that all the subclasses must be included. Now if you click this add remaining branches, it will automatically add the subclasses for us. Now let's remove this to do with curly braces. Inside these braces, let's use pet owner to call the respective print owner name function. So this print owner name belongs to this bird owner. Now let's copy this to all the subclasses. Now we can use pet owner here because Kotlin will smartly cast this to their respective type. So this pet owner is of type bird owner, and this is of type cat owner, and this is of type dog owner. Now let's go to main function, and inside this main function create an object of type bird owner and call this get owner name function and pass in bird owner as its type. Now this main function should print the name of this owner, which is John. So if we run this main function, you should see John being printed on this console. Now let's change this bird owner to dog owner, and let's pass in dog owner as an argument for this get owner name function. Now it should print a different name. So yes, it printed Bob. Now if we go to our dog owner subclass, yes, the name of the owner is Bob. So our get owner name function is doing what it should be, which is printing the name of the owner based on the type. Let's add one more subclass, and once you include this subclass, you will see how useful Seal class can be. So copy this subclass and paste it here. Now rename this from bird owner to fish owner, and then I'll call this owner as Bell. Now let's go to this function, and inside the function you will see the red underline on when expression, and if you move your cursor to this red underline, you will see an error message from the compiler, and the error message is same as before, and it is also saying that you need to handle the newly added subclass. But before handling that subclass, let's see one other thing, which is let's switch this from Seal class to an open class. Now if you go back to the function, you will see that the error is gone. Now if you run the main function, you will see it runs without any issues. This is because with an open class, the compiler is not aware of all the possible subclasses. And you saw an error with Seal class because Seal class has restricted hierarchies. Now let's reverse this back to Seal class, and if you go back to the function, you will see that error appears again. Now we just need to handle this newly added subclass. So here, and then add the remaining branches and just copy this and replace this to the to-do line. Now you see how Seal class allows us to manage subclasses efficiently, and it also ensures that all types are handled in the program, which means that any function will miss the newly added subclass. And you can extend as many subclasses as you want, but it should be within the scope of this project. You should use Seal class where you have a fixed set of closely related types, and you want to ensure all of these types are handled. So for example, handling success and error case. And finally, Seal class gives us control and predictability, which means that we can understand and anticipate how our code will behave based on the rules and the structure that we have defined. So this is all for this video, and if you find this video helpful, please like and subscribe. Thank you.